Welcome to the Battery Testing Mentor podcast. My name is Johannes Rössner, and here I discuss all topics around battery testing and battery handling. Short, on the point, and with actionable advice. Also visit www.batterytestingmentor.com and register there for the email update. With every episode you receive a short summary of the most important takeaways of that episode. And should you have any questions, comments, remarks or topics we should cover here, just reply that email and you directly reach me. With that, enough of the housekeeping, let's go into the episode. Are batteries dangerous? A question that often comes up and a question that is not so easy to answer because on the one hand, no, a battery in a stable, normal operation condition is not dangerous. On the other hand, you Google, you get on YouTube and see batteries, electric vehicles and huge fireballs, and of course you think batteries are dangerous. And because battery safety is one of the main reasons why I started this podcast, I wanted to pick it as the first topic and really map out together with you kind of where are the risks of a battery pack. Therefore, I brought here my iPad and together we will draw the map of the risks. In itself, these risks can be divided into several categories. On the one hand, we have the mechanical, the electrical, the thermal, and the chemical risks. On the other hand, we have the normal operation and kind of the accident outside normal operation. And let's go together through this matrix and fill it up. So let's start here with the mechanical risks on a normal operation. What comes to your mind first is of course the battery drops. Normal cells, they are maybe as heavy as such an iPad here. They are not really the big risk. Also, there are quite big cells, like maybe some of you know the BYD Blade cell, which is a huge cell of 1 meter length and is around 4 kilograms heavy. This is definitely something that if it falls on your feet, it hurts. But the point is that the more heavy the battery is, the more dangerous it becomes, like especially battery packs are hundreds of kilograms. If such a battery pack slips down from an elevator and then you are in between the battery pack and the floor, it definitely hurts a lot. And what's more about this drop is basically the accident, and there we get into this bottom area of our matrix, that if a battery drops, you damage the battery internally. The layers of the cells get moved, maybe get somehow impacted, and this can really lead then to an accident and something out of normal operation later on. And there are also these mechanical risks during an accident, which is when metal parts of the battery fly around. I mean, if the battery starts going into a thermal runaway, you have a lot of pressure inside, and when this pressure release, really parts, bolts, whatsoever can fly through the room. Also, again, we have to say this mechanical risk, like that some metal part is flying around, is kind of neglectable when you look at what can also happen during an accident. And there we look first into the thermal aspects, because if a battery goes into thermal runaway, it heats up, it really goes into the cycle where the heat leads to more heat release. So it really goes like an parabolic figure up the temperature, and at one point the electrolyte boils and you have the pressure, it releases, and in the worst case you have even fire. But even if there's no fire, there's really hot gases coming out. And in fire you have these gases even burning, really adding more heat to the effect. And this can really have effects far beyond the battery. Like if you look at this YouTube video again of an electric car burning, like it's not only the battery that burns, but in the end it's the whole car. Also, this heat will probably melt then the isolation of electric cables, and then you land at the electrical aspects. Because if the cables are melted, you suddenly have potentially contact with the cables to the case, to stuff around the battery. Inside the battery you have suddenly short circuits, you have electric arcs, and all of this can really create some situations where you don't want to be involved. And the other point in this accident is the chemical aspects. During a thermal runaway, a lot of stuff is released, and these chemicals, they are often very, very hazardous. They are really not good for your health. They can damage your skin, they can go into your blood and so on. And this is really something you should avoid. And even if there's a fire on top, you have then smoke, you have the gases from the burning, which is also not good. So we talk now about this accident, and it sounds horrific, but we have to be aware that this is really something that should not happen, that very seldom happens. It's not part of the normal operation. I mean, we have heard about a lot of battery fires, of electric cars burning, but if you look at the numbers, there are far more gasoline cars burning than electric cars. So it's typically a very small percentage, and only something that happens in rare cases. But if it happens, you need to be prepared. You should not freeze and then inhale all these gases or so, but know what to do. And the number one rule, if you can, is go away. Go as far away as possible. If you can't go away because you need to work on this battery or you need to extinguish it also, then wait maybe for a couple more episodes, and one day we will also talk about this, how to protect yourself. There is one additional aspect that normally I would say you can detect a battery going out of control. Like there are signs. It heats up, for example, doesn't perform as it should anymore. And then you can basically protect yourself early enough. But there are situations where it all goes within seconds, where the cell just has an internal short circuit, nobody noticed anything, and suddenly you have this extreme heat release, and within seconds, within 30 seconds, the whole battery pack is in fire. These are really situations that can happen. Again, it's very rare. Normally you can see it coming, but it's not a fixed rule that you see it and you don't need to care about. So you always need to be prepared what to do when a battery starts going into a thermal runaway. Nevertheless, we will leave it now here with this accident aspect and go back into the normal operation. We talked about the mechanical aspects. We still have the electrical, thermal and chemical aspects open, and I talk first now about the electrical, because this is what is on top of all our minds. Of course, don't touch it or you will be electrocuted and will die. Yes, but it's not that easy. Like a battery itself, if you have a battery pack in front of you, you normally can touch it everywhere and it's safe. Everything below pack, like cell and module, typically module, if it's below 60 volt, you can touch it anyway, and the voltage is so low that it won't harm you. But if you go to the battery pack, typically all the battery packs today have some computer inside that checks the status of the battery, makes sure that the battery is not lying somewhere, but it's built inside the car, for example, and it's everything that is around the battery is really working and is okay. only when you kind of simulate this, you can overrule the safety elements and then still activate the battery. But this is something that you really need to do. It's not that it happens by itself. However, there comes an but, and this is a story that I heard from a training once, like long time ago, where the trainer told us that he once went to a company to train them on their battery. The company prepared a battery for him that was safe, that was kind of deactivated. You could do whatever you like, and there should be no voltage, no live part. And then he went to the battery, and out of curiosity, he just measured, and suddenly he measured 200 volt at the contactors. So be aware, always be a little bit cautious. The reason that this happened was that in the company, somebody else prepared a battery for a test and had to manipulate the contactors so that they were always live. And he took the battery and just shortly put them into this area where this other battery was lying. And kind of the trainer then came to this place and thought this battery was his. So really be careful, be cautious, especially when you come to batteries that you don't know about. Try to find out first. I mean, there is also one thing like the battery, like an accompanying note comes to my mind that should be there and you should have a look at. Kind of be careful, be cautious, and be aware what is potentially there. The electrical risks are also there when you open the battery, but this is really something like going beyond the physical barrier that the battery has around itself. Like if you open everything, then it is very important that a battery cannot be shut down. Like there's the chemistry, it's always on. You can shut it down to the outside, but inside the battery pack, it's always there. So that was the electrical aspects. Let's go to thermal and chemical. Thermal means heat, hot surfaces. That is a point that can happen, but only when the battery is really operated, when it's charged and discharged, when there's a lot of current going in and you put the internal resistance, you have heat generation. Then the battery heats up, it can go to 60 degrees, 70 degrees. They're really performance batteries that are designed for very high temperatures to kind of ease the cooling. So you can have really high temperatures there. But you should not have then a battery lying on the hallway when you operate it, especially with high current. Like if you charge and discharge a battery, it needs to be in a room, in a test chamber that is access restricted, where nobody can just walk in and touch anything. So basically this thermal aspect is also not such a big deal. Remains the chemical aspect. Chemical means all this stuff that is inside the cell. When it comes out, it is hazardous. But again, we are talking about normal operation and the battery is sealed, the cell is sealed. Nothing of these chemicals should go out. If these go out, it means the cell has ruptured, it opened up, and then you are in this accident situation. So basically, from chemical point of view, and the normal operation should be fine. Of course, on battery pack level, there might be things like a cooling liquid that is in the battery that could potentially be harmful. We will talk about different types of cooling systems another time. If you just look at the battery itself, it's basically okay. So is everything no problem? There we are back at our question. Are batteries dangerous? And yes and no. It comes down to the fact that the battery is handled correctly. As long as you use it inside the operation condition and as long as you do not mishandle the battery, it's safe. The problem comes then when the battery is mishandled when you once have used the battery outside its operation condition and then basically don't say anything, or somebody forgot to mention it whatsoever, and you continue using it, and these internal problems start to build up. At one point it can really happen that such a dendrite forms, and then you have a short circuit, and within seconds it seems the battery starts a fire. But in reality it started long time before already to be kind of outside its operation conditions. I want to end with one recommendation that a former colleague gave me, who said, imagine a battery is a small baby and treat it accordingly. You don't leave a battery, a baby, sorry, in the cold. You don't leave a baby in the heat, in the sunshine. You don't throw a baby around. You treat it gently and make sure it is kind of always comfortable. With this, I want to close here. That was the Battery Testing Mentor podcast. I hope it was helpful for you, and hear you next time.